Now, earlier today, authorities say that 32 sailors had been rescued after the ship issued a distress call. Health Ministry official just a short while ago says that 7 are receiving emergency treatment. Details are still emerging, but that rescue effort is continuing.
Tension was already simmering in the Persian Gulf when something unusual happened beneath the surface. Early one morning, a U.S. cargo ship moving through the Strait of Hormuz suddenly slowed as alarms began echoing across its bridge. There was no missile warning, no radar alert, and no explosion in the sky. Yet somewhere below the waterline, the ship had been hit. Within minutes, American naval forces realized this was not a random accident. Hidden beneath the busy shipping lanes, an Iranian mini-submarine had executed a silent strike, one designed to test the limits of U.S. control in one of the world's most critical waterways. What happened next quickly turned a quiet ambush into a high-stakes naval confrontation. The moment the cargo ship was hit. At 8:12 in the morning, the American cargo vessel Liberty Pride was moving steadily through the Strait of Hormuz. The waters were crowded but calm. Tankers, container ships, and patrol vessels crossed the narrow corridor in a slow but constant rhythm. For the crew aboard Liberty Pride, it looked like an ordinary transit through one of the busiest shipping routes on the planet. Then, something strange happened. A sudden jolt ran through the hull. It wasn't violent enough to throw sailors off their feet, but it was strong enough to make everyone on the bridge pause. Seconds later, alarms began flashing from the engineering deck below. Sensors reported water entering a lower cargo compartment. At first, the crew suspected a mechanical failure, or perhaps debris floating just below the surface. But the damage report quickly told a different story. Steel plating beneath the waterline had been torn open. Seawater rushed into the compartment with frightening speed. Pumps were activated immediately as sailors raced to seal internal bulkheads. If the flooding spread, the ship could lose stability in the narrow channel. Yet what made the situation truly unsettling was what had not happened. No missile had been detected. No aircraft appeared on radar. No radio warnings had been issued. The ship had been struck silently. Within moments, the nearby U.S. Navy destroyer USS Gravely, which had been escorting commercial traffic through the region, changed course sharply toward the damaged cargo ship. The destroyer moved into a protective position between Liberty Pride and the open water beyond the shipping lane. On board Gravely, the Combat Information Center immediately began analyzing the situation. Operators checked radar feeds, satellite data, and aerial surveillance reports. Nothing in the sky explained the strike. That left only one possibility. The threat had come from below. Sonar systems aboard the destroyer were quickly activated to scan the surrounding waters. At first, the ocean sounded like chaos. The Strait of Hormuz is filled with acoustic clutter. Ship engines, propellers, echoes from the seabed, and reflections from wreckage scattered across decades of maritime activity. Detecting a submarine in such conditions is extremely difficult. For several minutes, the sonar screen showed nothing unusual. Then a faint signal appeared. It was brief, almost ghost-like. Just a thin acoustic trace moving slowly across the display. Normally, something that weak might be ignored as background interference. But the timing was too perfect to dismiss. The signal had appeared just minutes after the cargo ship was struck. Analysts froze the recording and began comparing it against known acoustic signatures stored in naval databases. Within seconds, the system flagged a possible match. The sound profile resembled an Iranian Ghadir-class mini-submarine. These submarines are small, extremely quiet, and specifically designed for operations in shallow coastal waters, like those of the Persian Gulf. Unlike large nuclear submarines that rely on speed and endurance, the Ghadir class focuses on stealth and surprise. Their mission is simple: hide, wait, and strike when the opportunity appears. According to naval analysts who have studied Iranian doctrine for years, these submarines are often used to test enemy reactions rather than sink large numbers of ships. They are tools of disruption. From Washington's perspective, the strike on Liberty Pride suddenly looked less like an isolated attack and more like a carefully calculated probe. Iran was not trying to start a naval battle. Instead, the strike appeared designed to answer a strategic question. How quickly would the United States detect the threat? And how far would it go to respond? As the damaged cargo ship struggled to control flooding, the destroyer USS Gravely continued scanning the water. Somewhere beneath the busy shipping lane, the submarine responsible for the attack was still there, waiting, and possibly preparing to disappear before anyone could stop it. The submarine that was never meant to be seen. As the sonar teams aboard USS Gravely continued scanning the water, the faint signal they had captured moments earlier began to take on greater importance. What initially appeared to be a weak and irregular acoustic trace now looked increasingly deliberate. It moved slowly, almost cautiously, through the cluttered underwater environment of the Strait of Hormuz. For analysts watching the data stream, the pattern raised an unsettling possibility. This was not random noise. It was something alive beneath the water. The signal matched the acoustic profile of an Iranian Ghadir-class mini-submarine, one of the smallest operational submarines in the region, but also one of the most difficult to detect. Unlike large submarines that generate clear acoustic signatures through powerful engines and propellers, mini-subs like the Ghadir class are designed to operate almost silently. Their diesel-electric systems allow them to move slowly with minimal noise, especially when operating on battery power. In shallow waters, that advantage becomes even greater. And the Persian Gulf is one of the most challenging underwater environments on Earth for submarine detection. The seabed is uneven and cluttered with debris from decades of maritime traffic. Old shipwrecks, discarded anchors, and twisted metal structures create thousands of false sonar reflections. Every passing cargo ship adds to the confusion. Propellers churn water, engines vibrate through the hulls of massive tankers, and sound waves bounce unpredictably across the narrow corridor. To sonar operators, the environment often looks less like a clear picture and more like static on an old television screen. This chaotic background noise is exactly what Iranian planners have counted on for years. Military analysts have long noted that Tehran's naval strategy in the Gulf focuses on asymmetric warfare, using smaller, cheaper platforms that exploit geography rather than attempting to match the United States ship for ship. Mini-submarines are a key part of that approach. These vessels can hide along the seabed, sometimes resting motionless for long periods, while commercial ships pass overhead. In that position, they blend into the underwater terrain. Engines can be shut down completely, leaving the submarine nearly silent except for the faint electrical activity needed to support life inside. For sonar systems searching for movement or noise, a submarine that refuses to move becomes incredibly difficult to detect. Iranian naval exercises have demonstrated this tactic repeatedly. Instead of chasing targets through open water, mini-subs often wait in ambush, allowing commercial shipping traffic to mask their presence. When the moment is right, they strike quickly before slipping back into hiding. From Tehran's perspective, patience becomes a weapon. Evidence suggested that the submarine responsible for hitting Liberty Pride had followed exactly that playbook. For nearly 2 days, it had likely been resting on the seabed somewhere along the shipping route. With engines powered down and most onboard systems inactive, the vessel would have produced almost no acoustic signature. Above it, dozens of ships crossed the strait every hour. The noise from those vessels acted like camouflage. Then, when the cargo ship passed directly overhead, the submarine launched its attack. The weapon used was believed to be a lightweight torpedo or naval mine, something designed to damage a ship without completely destroying it. Moments later, the submarine retreated. But it did not flee toward open ocean. Instead, sonar analysts noticed something unusual about the faint signal moving across their screens. The contact was heading toward the Iranian coastline. At first glance, this might have looked like a simple escape attempt, but to American planners, it revealed something more deliberate. Iranian naval doctrine often relies on drawing opponents closer to the coast, where defensive advantages increase dramatically. Coastal radar systems, anti-ship missiles, fast attack boats, and surveillance networks create layers of protection that make aggressive pursuit risky. In such areas, even a powerful navy must weigh every move carefully. The submarine crew likely believed they had already completed the hardest part of the mission. They had struck a target. They had avoided immediate detection. Now, all they had to do was slip back toward the safety of Iranian waters. For a few minutes, that assumption seemed reasonable. The submarine moved steadily toward the coast, confident that distance and political caution would protect it. But inside American command centers monitoring the situation, the picture was changing quickly. Multiple surveillance systems were now tracking the same contact. Sonar data from the destroyer, signals from maritime patrol aircraft, and intelligence analysis flowing through naval command networks. Piece by piece, the underwater puzzle was coming together. The silent attacker had been found. And this time, it was the submarine that was being watched, tracking the escape toward the coast. As the Iranian mini-submarine moved steadily toward the coastline, the crew inside likely believed the most dangerous phase of their mission had already passed. From their perspective, the strike had succeeded. The cargo ship had been damaged. The attack had occurred without warning, and the submarine had escaped the immediate area without being intercepted. In many previous encounters in the Persian Gulf, this was exactly how such operations ended. A quick strike followed by a quiet withdrawal into coastal waters, where pursuing forces would hesitate to escalate. Iranian naval doctrine has long depended on this assumption. The closer hostile forces move toward Iran's coastline, the more complicated the situation becomes. Coastal missile batteries, radar installations, patrol craft, and surveillance drones all create a layered defensive network designed to discourage aggressive pursuit. For foreign navies, chasing a submarine into those waters can quickly become a political as well as military decision. That was the protection Iranian planners expected. Inside the submarine's narrow control compartment, the crew monitored navigation displays and sonar readings while the vessel crept forward on battery power. The water grew shallower as they approached the coastline, and the background noise from coastal traffic made detection even harder. Everything seemed to be unfolding exactly as planned. But what the crew could not see was the growing web of surveillance forming around them. The faint acoustic signature first detected by USS Gravely had now been confirmed by multiple systems. Naval analysts compared the submarine's movement patterns with satellite observations and historical traffic routes used by Iranian mini-subs during training exercises. The contact was no longer just a possibility. It had become a tracked target. Unlike older naval operations that depended on a single ship's sonar, modern U.S. naval surveillance relies on combining information from several platforms at once. Destroyers, patrol aircraft, satellites, and underwater sensors feed data into a shared operational picture. Each individual system may see only part of the environment, but together they form a clearer view of what is happening beneath the surface. In this case, that integrated picture showed something critical. The submarine was not racing away. It was moving slowly and predictably along a path that led directly toward Iranian territorial waters. American commanders watching the situation understood the strategic implications immediately. If the submarine reached the heavily defended coastal zone, any attempt to strike it could risk triggering a wider confrontation. That meant time was limited, but rushing ships closer to shore would only play into the submarine's advantage. Iranian coastal defenses are specifically designed to threaten vessels that approach too aggressively. Instead, U.S. commanders chose a different approach. Rather than moving the destroyer closer, they relied on standoff capabilities, weapons and platforms capable of engaging targets from outside the immediate danger zone. High above the Gulf, a U.S. maritime patrol aircraft was already orbiting the area. Aircraft of this type are designed for anti-submarine warfare. Equipped with advanced sensors, they can monitor underwater movement and deploy specialized weapons capable of targeting submarines even in shallow waters. As the submarine continued its slow approach toward the coastline, analysts fed updated position data to the aircraft. The window for action was narrowing. Inside American command networks, officers reviewed the rules of engagement carefully. The goal was not to destroy the submarine outright, which could escalate the situation dramatically. Instead, the objective was neutralization. If the submarine could be disabled without sinking it or causing heavy casualties, the message would be clear without triggering a full-scale crisis. Moments later, the aircraft adjusted its flight path. From high above the Persian Gulf, far outside the reach of coastal defenses, it moved into a position where its onboard weapons could enter the water directly along the submarine's projected route. Below the surface, the Iranian vessel continued forward. The crew believed they were only minutes away from the protective umbrella of their own coastline. They slowed slightly, preparing to navigate into the shallower coastal zone. Then the ocean around them changed. Sensors aboard the submarine suddenly detected unusual pressure waves moving through the water. At first, the signals were confusing, too brief to identify clearly. But within seconds, the pattern became unmistakable. Something had entered the water nearby, and it was moving fast. Above them, the U.S. aircraft had just deployed a guided anti-submarine weapon, designed to track underwater targets with precision once it entered the ocean. Unlike older depth charges that relied on wide explosions, this system used advanced guidance to follow subtle changes in pressure and movement. It was not meant to blanket the ocean with force. It was meant to find one target, and the target was already in its path. Inside the submarine, alarms began to flash across control panels as sonar operators realized what was happening. The ambush had just turned around. Now the hunter had become the hunted. The precision strike beneath the surface. Inside the Iranian mini-submarine, the atmosphere changed instantly. Only moments earlier, the crew believed they were approaching safety. The Iranian coastline was not far away, and once inside the layered network of coastal defenses, pursuit by foreign forces would become politically complicated. But now, the sonar console told a different story. A fast-moving object had entered the water nearby. At first, the signal appeared as a brief spike on the display, cutting through the background noise of the Gulf. Within seconds, the pattern grew clearer. It was not drifting debris or a passing vessel. It was moving directly toward them. The submarine's sonar operator quickly reported the contact to the commanding officer. Inside the cramped control room, tension rose as officers tried to determine what they were facing. Iranian mini-submarines are built primarily for stealth and surprise, not for surviving prolonged engagements. Their small size and limited defensive systems mean that once they are located, their options are extremely limited. The captain immediately ordered evasive action. Electric motors increased power as the submarine attempted to change direction and descend slightly toward the seabed. In theory, moving closer to the bottom could make it harder for an incoming weapon to maintain a lock. But the maneuver came too late. The weapon deployed by the U.S. patrol aircraft had already entered its guidance phase. Unlike older anti-submarine munitions that detonated blindly, modern systems are designed to track targets with remarkable precision. After hitting the water, the weapon releases a small torpedo-like device that actively searches for its target using acoustic sensors. Once it identifies a submarine, it adjusts course automatically. As the weapon closed the distance, the Iranian crew attempted to deploy countermeasures. These typically include acoustic decoys designed to confuse incoming torpedoes by imitating the sound of the submarine's engines. But mini-submarines like the Ghadir class carry only limited defensive systems. Their mission depends on avoiding detection in the first place. Once found, their survival chances drop sharply. Within moments, the incoming weapon adjusted its path and locked onto the submarine's acoustic signature. The closing distance left almost no time for further maneuvers. Then, the detonation occurred. The explosion was not massive, but it was extremely precise. Instead of tearing the submarine apart, the blast struck near the vessel's propulsion system. The shockwave rippled through the hull, disabling critical components that allowed the submarine to maneuver. Inside the vessel, lights flickered as power systems fluctuated. Control panels erupted with warning signals. The propulsion motor shut down almost instantly, and the submarine lost its ability to maintain controlled movement underwater. Steering mechanisms jammed as hydraulic systems failed. Within seconds, the crew realized the submarine was no longer fully operational, but it was still intact. This outcome was not accidental. American commanders had deliberately chosen a weapon and strike profile designed to produce what military analysts call a mission kill. The goal was not to destroy the submarine outright or cause heavy casualties. Instead, the strike was meant to remove the vessel's ability to continue its mission while avoiding the dramatic escalation that could follow the sinking of a foreign military asset. In politically sensitive waters like the Persian Gulf, that distinction matters enormously. Destroying the submarine could have triggered retaliatory missile launches from Iranian coastal defenses or attacks by fast patrol boats in the region. Disabling it sent a powerful message without crossing that dangerous line. As the damaged submarine struggled to maintain stability, its internal systems continued to fail one after another. Without functioning propulsion, the vessel could no longer remain submerged safely. Slowly, under the watch of American surveillance systems above, the submarine began rising toward the surface. For the crew inside, the mission was effectively over. Above the water, U.S. aircraft continued circling the area, while naval forces monitored the situation closely. Electronic sensors confirmed that Iranian coastal radar stations had detected the activity. Signals traffic from shore increased noticeably, yet no missiles were launched. Iranian forces activated defensive systems and tracked the American aircraft, but they stopped short of firing. The confrontation had reached a delicate balance. Both sides understood that further escalation could transform a limited incident into a wider conflict. When the submarine finally surfaced, the tension that had built beneath the Gulf began to ease. The vessel had not been destroyed, but it had been neutralized. From Washington's perspective, the objective had been achieved. The threat had been removed, the shipping lanes remained open, and the situation had been contained without triggering a larger military crisis. But the consequences of the encounter were only beginning to unfold. Because once the submarine surfaced, damaged, exposed, and unable to disappear again, the strategic problem for Iran had just begun. Tehran's strategic dilemma after the strike. When the Iranian mini-submarine finally surfaced in the waters near the coastline, the immediate confrontation in the Persian Gulf had effectively ended. There was no dramatic naval battle, no exchange of missiles, no sinking vessel disappearing beneath the waves. Instead, the submarine floated on the surface, damaged, exposed, and unable to return to the depths where it had once hidden. For Iran's naval command, that outcome created a far more complicated problem than the attack itself. Only hours earlier, the submarine had been an invisible weapon. It represented stealth, unpredictability, and the ability to challenge American forces in a region where geography favors smaller, unconventional tactics. Now it had become something else entirely, a liability. Reports from maritime observers and defense analysts suggested that the strike had severely damaged the submarine's propulsion and steering systems. While the vessel remained structurally intact, its ability to maneuver underwater had been effectively eliminated. In submarine warfare, mobility is everything. Without propulsion, a submarine cannot dive safely, evade threats, or reposition itself in combat. It becomes little more than a floating platform waiting to be recovered. That meant Tehran faced two immediate choices. The first option was to tow the submarine back to port for repairs. At first glance, this might appear to be the most logical response. Recover the vessel, repair the damage, and return it to service. But in reality, repairing a submarine is an extremely complex process. Even relatively small damage to propulsion systems can trigger a cascade of technical problems throughout the vessel. Electrical wiring, hydraulic systems, pressure seals, and navigation equipment all depend on precise alignment. If one major component fails, many others must be inspected or replaced. For a mini-submarine like the Ghadir class, which relies on compact and tightly integrated systems, the repair process could take months or even years. And that is where Iran's second challenge emerged. International sanctions have placed severe restrictions on Tehran's ability to obtain advanced maritime components. Replacement parts for propulsion systems, sensors, and electronic equipment are often difficult to acquire without relying on improvised solutions. Engineers may be forced to substitute parts, rebuild damaged systems manually, or operate with limited technical support. Each of these workarounds carries risks. Even if the submarine were eventually repaired, its performance might never fully return to its original level. But the second option facing Iranian commanders was even more dangerous. Allowing the damaged submarine to remain exposed, especially under the watchful eyes of U.S. surveillance systems, risked something far worse than repair costs. It risked intelligence exposure. Modern submarines are far more than simple underwater vehicles. They are complex networks of technology, including sonar systems, communication equipment, navigation software, and stealth materials designed to reduce acoustic signatures. If foreign analysts gain access to those systems, they can learn how the submarine operates. They can study its acoustic fingerprint. They can analyze the layout of its sensors. They can examine how its propulsion system generates noise. That kind of knowledge is incredibly valuable. Once a submarine's acoustic signature becomes known, detecting similar vessels in the future becomes much easier. What was once a hidden threat becomes predictable. For the United States, intelligence obtained from a damaged submarine could reveal details about an entire class of Iranian naval platforms. From Tehran's perspective, that possibility was deeply troubling. Protecting military technology is often as important as protecting the platform itself. If the internal systems of the submarine were compromised or studied too closely, the stealth advantage that Iranian naval strategy depends on could be weakened. That meant Iranian commanders had to move quickly. Recovery vessels and support ships were reportedly mobilized along the coastline to assist the disabled submarine. The goal was simple: secure the vessel before any opportunity for foreign intelligence exploitation emerged. But even if the submarine were successfully recovered, the strategic damage had already been done. The attack had been meant to demonstrate Iran's ability to disrupt shipping in one of the world's most critical maritime corridors. Instead, the incident had revealed something else. The United States had detected the submarine, tracked its escape route, and neutralized it without escalating the conflict. The silent ambush had turned into a strategic setback, and that raised a larger question for naval planners on both sides of the Gulf. Had the balance of undersea warfare in the region just shifted? How the U.S. Navy turned the ambush around? From the outside, the encounter in the Persian Gulf looked simple. A submarine struck a cargo ship. American forces responded. The submarine was disabled. But beneath that sequence of events was something far more complex. The reason the United States was able to locate and neutralize the Iranian mini-submarine was not luck or a single advanced weapon. It was the result of a layered system designed to track threats even in the most difficult environments. For decades, submarine detection relied primarily on sound. Ships and aircraft listened for engine noise, propeller vibrations, or mechanical signatures that could reveal a vessel hiding beneath the water. But in places like the Strait of Hormuz, traditional sonar often struggles. The narrow corridor is one of the noisiest maritime environments on Earth. Hundreds of commercial vessels pass through the strait every day. Their engines, propellers, and hull vibrations create a constant wall of sound that spreads through the water. Add to that the reflections from the seabed and underwater debris, and sonar operators are left with a chaotic acoustic picture. Iran's submarine strategy was designed specifically to exploit that chaos. Mini-submarines such as the Ghadir class are small, quiet, and capable of shutting down most onboard systems to minimize their acoustic footprint. When resting motionless on the seabed, they can become extremely difficult to detect using traditional listening techniques. Iranian naval planners have practiced this tactic for years. A submarine hides among wreckage or underwater terrain, waits silently while ships pass overhead, and then launches a quick attack before disappearing again. Against older detection systems, this approach could be extremely effective. But the U.S. Navy has spent years preparing for exactly this kind of challenge. Instead of relying on sound alone, American naval operations increasingly focus on behavioral detection. Rather than asking only what can be heard, analysts ask a different question. What should be moving, but isn't? In a dynamic maritime environment, nearly everything changes constantly. Currents shift debris, ships move across shipping lanes, and underwater noise fluctuates as traffic passes through the strait. When an object remains completely still for long periods of time, it becomes suspicious. That was one of the clues that led analysts toward the submarine. Data collected from sonar readings, satellite monitoring, and historical traffic patterns revealed an unusual anomaly along the shipping corridor. Something solid had remained in place for nearly 2 days, despite the constant movement around it. At first, it looked like another piece of seabed debris, but its shape was too regular, its outline too smooth. Gradually, analysts began to suspect the object was not debris at all. It was a submarine lying quietly against the seabed. Another critical advantage came from the distance maintained by American forces during the encounter. Instead of rushing ships closer to the Iranian coastline, where coastal missile batteries and fast attack craft could threaten them, U.S. commanders kept their most powerful assets outside the immediate danger zone. This allowed American surveillance systems to operate with far less risk. Maritime patrol aircraft circled high above the Gulf, scanning the waters below with advanced sensors capable of detecting subtle disturbances. Undersea monitoring systems collected additional data, feeding information back to command networks that combined every available signal into a single operational picture. Each system alone might not have been enough to locate the submarine. Together, they created clarity. Technology also played a key role in another area: non-acoustic detection. Even the quietest submarine leaves physical traces behind. Large metal objects disturb the Earth's magnetic field slightly, creating what scientists call a magnetic anomaly. Specialized sensors can detect these disturbances and help confirm the presence of underwater vessels even when they remain silent. Modern anti-submarine warfare increasingly combines acoustic and magnetic detection methods, making it harder for submarines to rely purely on stealth. This layered approach, combining sonar analysis, behavioral pattern recognition, aerial surveillance, and magnetic sensing, gave American forces the advantage they needed. Once the submarine was identified and tracked, the final decision came down to how to respond. Rather than destroy the vessel outright, the United States chose a more controlled option: disable the submarine, expose the tactic, avoid escalation. The precision strike that followed achieved exactly that. From a military perspective, the encounter demonstrated something important. Iran's stealth tactic had worked, at least initially. But once detected, it had very few ways to survive. And that realization changed the strategic balance beneath the waters of the Persian Gulf.